As always, first things first, let's understand methods in all their glory. So far, the code we have written is, well, pretty sequential. I think you'll agree with me on that. In the previous module, we have the ifs and the whiles that allowed us to jump between different branches or repeat certain parts of the code. But still, in general, our code is one large block. Say that we have written code that calculates the wage of the employee. That would be code that we may wish to call several times while running the application. Now, it wouldn't be the best idea in the world to write that code several times now, would it? Because wage calculation, it'll change over time. If we'd have that code several times in our application, we'd have to make a change in several places. The solution, well, is pretty straightforward. We'll write the code in one place and call it. That place is a method, and while the name methods might not ring a bell, maybe the word function or subroutine does. Methods are pretty much the same. But so, what are they really? Methods are very common to use in C#. They are code blocks which contain a number of code statements. They'll have a name, and by calling that name, we can invoke the method and thus the code that lives within that method. Methods can be any size. They can contain just a single line or contain a whole bunch of statements. Frequently, methods will define that they require one or more parameters in order to run, and thus when we call the method, we need to pass in a value for these parameters. The values that we are passing in are called arguments. Methods can be used to define functionality to do all sorts of functionality, and based on that, they can optionally also return a result to their caller. By placing our code in methods, and thus not creating a long list of statements, we definitely improve the readability of the code. But not only that, methods also help with code reuse. When creating applications, you'll often do the same thing as I mentioned before. By putting this functionality inside of a method, you can invoke that method from different places within your application, hence improving code reuse. Finally, methods always need to be declared inside of a class or a struct. You may ask, what are they? Well, they are very important building blocks for C# applications that we will look at soon. Methods are in fact always declared inside of a class or a struct. That will become clear soon enough. Just keep this in your brain tucked away for now. That'll do. Methods are always created with pretty much the same structure. In general, you'll always see the same items come back when defining a method. On this slide, I've captured the general structure of a method. A method has to have a name and requires two brackets behind this name. Then, the actual method statements, so the body of the method, goes between two curly braces. Essentially, the items in orange are required. In fact, what is also required is the return type, which indicates what type of result will be returned from the method. It's possible that the method isn't returning anything. Then still we need to indicate this with a void return type. More on that soon. A method can optionally also define it requires one or more parameters. These need to go between the brackets. Essentially, the parameters are declared as if we are defining variables, using a type and their name. When two or more parameters are defined, the parameter list needs to be comma separated. And if there aren't any, we still need to add the brackets, but just leave them empty. Finally, it can optionally also have an access modifier defined. Now we'll talk about access modifiers later. For now, remember that this can be used to indicate from where this method can be invoked. All of this together is what is referred to as the method signature. Here is a first method. They almost don't come any simpler. The method's name is addTwoNumbers. It has an int return type and it is publicly available. Pretty simple, isn't it? Now a method named addTwoNumbers, which doesn't receive the two numbers to add, well, that doesn't make a lot of sense now, does it? That's why next I'm going to add two parameters. Int a and int b are these parameters. Now the method signature defines that when someone wants to call this method, they will need to pass in two integer values, which will go in this a and b variables. Just to be sure, notice that we need to specify here the type of the parameters, so int before a and b. If we would try to compile this code, it would actually give us a compile time error. Any idea why? Well, the answer would be the method has a return type specified, the int here. But when doing so, the method must do what it says. It should actually also return an integer value at the end of the method body. With this line added now, return a plus b, this will be the case, and the compiler will be happy. Return is another C# keyword that essentially stops the execution of the method and returns the value here to the caller, and thus also the execution returns to the caller. And when saying the caller, I mean the code that will call or invoke this method. And we'll see this in just a minute. Most often, the return statement will be at the end of the method. When a method defines its returning an int, in fact, all code execution paths should do this. Again, otherwise, you will get a compiler error. It is possible that the code inside of our method has multiple execution paths due to, for example, an if statement again. Say that we indeed include an if statement like you see here on the slide. There's a possibility that no value is being returned from the method. That would be if b would be greater than a. C#'s compiler won't allow this to go through, and it will raise an error. You should also include code here that returns a value for the case a is less than b, at least. But now what if the code in the method just performs a task, say show text on the console? What should it return then? Well, great question. It is not required for a method to just return anything. The only thing C# requires is that we then indicate this. For this, we have the void return type. This is an indication that the caller shouldn't be expecting anything to come back from the method, and the method now also doesn't need to include a return statement. Now, once we have defined the method, we can also invoke it or call it. That's the same. If I have that displaysum method, so the void method I just showed you, we can now invoke it by calling displaysum. And then between the brackets, we now need to pass in two values of type int, since that was in the method signature. These values, so the values that we pass to a method, are the arguments that we use when invoking the method. For each parameter defined in a method declaration, an argument must be provided when invoking the method. The arguments provide the values for the method parameters. The different arguments are comma-separated, as you can see here. Oh, and one more thing. The method name has to match exactly, so including the casing. C# is case sensitive. I do understand that calling displaysum basically changes the flow of execution again. Instead of continuing to execute statements over here, the statements in the displaysum method are executed. And only when the displaysum is finished executing will the flow of execution return back here. Now, our displaysum had the void return type, so it's not returning anything to the caller. And that is different for the addTwoNumbers method, which was returning us the sum of its two parameters as an integer value. So we can assign the returned value of invoking addTwoNumbers to a new variable, here called result. Result will contain after execution here the value 99 and can then be used locally here. Instead of directly passing values as arguments, we can also pass in the name of variables. Here you can see that I have defined two local variables, p1 and p2. We're now calling displaysum like before, but now we are passing in the variables instead. This is something you'll do often